morning, everyone. So, in this session, we will see the module 2, which is the dynamic force analysis of slider crank mechanism. So, in this slider crank mechanism, the piston, its reciprocating motion is converted into the rotary motion of the crankshaft. So, on the piston, the various forces are acting. We have to find out the forces on the piston, forces in the connecting rod, and forces on the crank. So the first force which is created on the piston, it is because of the combustion. So the combustion pressure, it will act on the cross-sectional area of the piston. That pressure is a P. And because of this P, a force is created on the piston that is called as Fl. Now this Fl, it is being opposed by the inertia. So this is the Fi. Okay. Now the summation of Fl and Fi, it will act on the piston that is called as net effort. So piston moves in the forward direction because of this net effort Fp. Out of this Fp, some force is transmitted in the connecting rod. That force is called as Fq. Some force will act on the crank exactly in the perpendicular direction. So this force is called as Ft. And this Ft will create the necessary turning moment, that is the M. So from this Fp, you have to find out this turning moment. So let us see what is the mathematical analysis. So this is the schematic diagram, the force diagram. Now from this force diagram, we can find out various components. So first formula we should know, this is about the inertia force. So inertial force, it is given by Fi, and this is equal to the mass of the piston into the acceleration. So M, and this acceleration has a formula R omega square in the bracket cos theta plus cos 2 theta divided by n. And where this n, this is called as obliquity ratio, and this is given by n is equal to L upon R, where L is the length of the connecting rod, R is the crank radius. So from this we can find out the Fi. So this is the first formula. Second formula we should know is about the net load. So load on the piston. So this load on the piston, it is because of the combustion. So it is represented as a FL. So FL is equal to the pressure into the cross-sectional area of the piston. If the engine is a double acting, then this is written as P1A1, that is pressure on one side and area of the one side minus pressure on the other side into area of other side. Okay, so this is the FL. So this is for single acting and this is for the double acting. From these two forces, Fl and Fi, we can find out the net effort. So this net effort, so it is represented as a Fp. So Fp is equal to Fl minus Fi. Okay, and this formula, this is for horizontal engine. If the engine is vertical, then we have to consider the weight of the piston. So it is Fl minus Fi plus the weight of the piston. So this is for vertical engine. Okay, so this is the formula for net effort, that is F. Now this Fp, it will get transmitted along the connecting rod and on the crankshaft. Okay, so let us see how the force is transmitted. But basic, we should know these three formulae. One is for Fi, second is for Fl, and third for the Fp. Okay, now let us see the force diagram, how the forces are transmitted. So now we know that net effort on the piston, so that net effort is represented as F. Okay, out of Fp, some force is transmitted along this connecting rod. That force is called as Fq. Okay, some force will act in the normal direction on the cylinder wall. So this normal force is called as Fn. Okay. Now these three forces will create one triangle. So if I take this Fn here like this, we will get one right angle triangle. So this right angle triangle will be like this. This horizontal component, it is the Fp. This vertical component, it is the Fn. And this resultant, this is the Fu. Okay. Now this connecting rod angle, it is taken as a phi, and this crank angle, it is taken as a theta. Okay. Now let us find out first relation between this FQ, FP, and Fn. Just we have to use basic trigonometry. So here we can write Fp. This is equal to, as Fp is a cos component of Fq, so it is Fq into cos phi. Okay. So this is the first relation we get for Fp, and from this we can get Fq is equal to, it is Fp upon cos phi. Okay. Second relation for Fn. Fn is equal to, it is opposite component of Fq, so it is Fq sin phi. So this is the second relation for Fn. One more relation we can get if I use a tan of phi. So basic formula for tan is opposite upon adjacent. So it is Fn upon Fp, and therefore Fn is equal to, it is Fp into tan phi. Okay, so we get two relations for Fn. One is Fq sin phi and second is Fp tan phi. Okay, no need to remember these equations, just remember this basic triangle. Now out of Fq, if I extend this line, so Fq will continue to act along this line. Okay, so this line represents the Fq. Now some part of Fq acts exactly perpendicular. So this perpendicular is called as Ft. Okay, so force acting on the crankshaft. And some part of Fq acts along the crankshaft. So this is called as Fb. Ultimately, it will act on this bearing. So this is the Fb. Now here we have to see the relation between Ft and Fq. So for that, just make one construction, draw one horizontal line. Now this angle and this angle will be same. So this is a phi. This angle and this angle theta will be same. So this is a theta. So this total angle, it will be theta plus phi. So Ft, it is the opposite component of Fq. So we can write here Ft is equal to, it is Fq sine theta plus phi, and Fb, this is equal to Fq cos theta plus phi. Now this Ft, it will create the turning moment. So this turning moment is M. So turning moment, so it is given by M, this is equal to Ft into the crank radius. Okay, so when we solve the problem on the slider crank mechanism, we must know this formula. One for Fp, Fn, next is Ft, then turning moment, then force on the crankshaft bearing, that is the Ap. Okay, and the basic formula from which we can determine this Fp. So that formula is Fl minus Fi. Fl is the load, so it is from P1A1 minus P2A2, or just P into. Okay. And Fi is the inertia. So this is the formula for inertia force. Now let us see some problems on this ladder crank mechanism. So let us take the first problem. So here the crank pin circle radius of a horizontal engine is a 300 mm. The mass of the reciprocating part is 250. So question, it is for the horizontal engine. So you can draw a schematic diagram. So this is the piston part, and it is reciprocating in this cylinder. This is the connecting rod, and this is the crankshaft, and this is the crankshaft bearing. Okay, and draw one reference line. Now here what is given? The crank pin radius. Crank pin radius means this is the crank pin radius where the connecting rod and the crankshaft are connected. This radius is nothing but r. That value is given 300. So this is 0.3 meter. The mass of the reciprocating part means mass of the piston is given. Reciprocating means it is a piston that is equal to 250 kg. When the crank has traveled 60 degree from the IDC, IDC means inner dead center. It means from this side motion has started. Okay. So when the crank has traveled 60 degree, means this theta is given 60 degree. You can write theta. This angle is at 60 degree. The difference between the driving and back pressure is a 0.35 Newton per mm square. Okay. So driving and back pressure means this value is given P1 minus P2. This is equal to 0.35 Newton per mm square. So this is the meaning of driving and back pressure. The connecting rod length between centers is 1.2 meter. So this length L is equal to 1.2 meter. So L is equal to 1.2 meter and R is equal to 0.3 meter. And the cylinder bore diameter is 0.5 meter. Okay, it means if this is a piston, then this bore diameter, so this is given. Let us take this as a D and this is equal to 0.5 meter. If the engine runs at 250 rpm, so engine rpm is given. So N is equal to 250 rpm. From this N, we can find out the omega. Is 2 pi N divided by 60. So if you calculate this value, omega is a 26.2 rad per second. From this D, as diameter on both the side of piston is same. Okay, so we can take this A1 and A2. Both are pi by 4 D square. Okay, and from this you can find out that area. Okay, just calculate this area. Okay, so you have to find out first is pressure on side wall, thrust in the connecting rod, tangential force on the crank pin, and turning moment on the crankshaft. Okay, so first we have to find out the FP, that is the net effort. Okay, so we can write the formula for FP. So FP, which is the net effort, this is equal to Fl minus Fi plus, as the engine is a horizontal, so weight of the crankshaft will not weight of the piston, okay, will not affect this FP. So just it is Fl minus F. So first calculate the Fl, which is a load on the piston. This is equal to P1A1 minus P2A2. Now here area is the same. So we can take P1 minus P2 into the area. So this P1 minus P2 is given. It is 0.35 Newton per mm square. So this is equal to 0.35. As it is Newton per mm square, you have to multiply. Convert that mm square into meter square. So mm into meter will be 10 to the power minus 3 square. So it will be 10 to the power 6. So this is Newton per meter square into this area is pi by 4 d square. So this is pi by 4 into 0.5 square. Okay. And from this we will get the FP. This is 68,730 Newton. So this is the value of F. Next, now calculate the inertia. So Fi is equal to, formula is mr omega square cos theta plus cos 2 theta divided by n. Okay. So first calculate the n value. So n is equal to L upon R. So L is 1.2 and R is 0.3. So this is 4. Okay. Now put all the values. Mass of the piston is 250. Radius of crankshaft is 0.3. Omega is 26.2 square. Cos 60 plus cos 2 theta means cos 120 divided by n is 4. Okay. So from this find out the value for Fi. So that Fi is 19306 Newton. Okay. Now from this both the formula FL and Fi, find out this Fp. So Fp will be 68730 minus 19306, and that is equal to 49424. Okay. Now this is the force Fp. Now we have to find out what is the pressure on sidebar. Means we have to find out the force acting on the wall. So here we have to find out this Fn. Okay. So let us use the trigonometry. Now we have Fp. Then consider this triangle. This is the Fq and this is the Fn. Okay, and this angle is of phi. But here phi angle is unknown. So again consider that geometry. So this is the geometry. This angle it is 60. This angle is unknown, which is a phi. This force or this length, so that length is given in the problem. It is 1.2 and this is 0.3. So this is 1.2 meter. This is 0.3 meter. Okay. In the geometry, there is one basic rule which is called as a sine rule. So by using sine rule, we can find out this phi. Just write the relation. This length 1.2 upon sine of opposite angle. So it is sine 60. This is equal to 0.3 upon the sine of opposite angle. So sine phi. Okay. If you solve this, you will get the angle phi. That angle phi, this is equal to 12.5 degree. Okay. So if the phi is not given, just by using this basic sine rule in the geometry, you can find out the unknown angle phi. Now the phi is known. Now just write the equation. The first equation will be Fn. This is equal to Fp, as it is opposite, means Fp sine phi. Fq, this is equal to Fp upon the cos phi. Okay, now use these two equations and find out the Fn value and the Fq value. So Fn is equal to 10,960 Newton and Fq value is 620 Newton. Okay, 50,620 Newton. So you will get these two values. Yes, you can verify this answer. Okay. Answer may be slightly different. That depends on the decimal places. But near about you will get the answer 10,000 and 50,000. Okay, now we got the two answers Fn and F. Now the question is we have to find out the thrust in the connecting rod. So Fq is nothing but the thrust. Thrust means force. Thrust in connecting rod. Okay, so this is the second question. Third question is we have to find out tangential force. So tangential force means If we consider this slider crank mechanism, this is the piston, this is the crankshaft. So we know that this value, this is nothing but Fq. One force get transmitted like this. So this is the Ft. Okay. So here, as we know that along this line, the Fq remains same. This angle is phi, this angle is theta, and one force acts along the crank, so that force is AB. We should remember this second diagram also. We can get the value of Ft. So Ft, this is equal to Fq sine theta plus phi. Okay. So Fq is known, which is of 50,620. Sine theta is 60 degree and phi is 12.5 degree. Okay. So if you solve this, then you will get the value for Ft as 48,280 Newton. Okay. So to calculate this Ft, you remember this diagram. Okay. Just extend the Fq like this. Find out the perpendicular Ft and along AB by basic resolution. Okay. So this is the Ft. And from the Ft, so to find out what is the turning moment. So turning moment, so it is m, that is equal to Ft into the radius. So Ft is 48,280 into the radius is 0.3 meter. So this radius, this is r, 0.3 meter. This Ft times radius is nothing but m. So that is equal to, okay, so it is 14,484 Newton meter. So in this way, we can find out the various forces and the turning moment in the slider crank mechanism. Now see the second question. So here, a crank and now see the second question. The crank and connecting rod of petrol engine running at 800 rpm are 50 mm or 200 mm respectively. The diameter of the piston is 80 mm and the mass of the reciprocating part is 1 kg. At a point during the power stroke, the pressure on the piston is 0.7 when it has moved 10 mm from the air dead center. Then determine the net load on the gudgeon pin, thrust on the connecting rod, reaction between the piston and cylinder, and the engine speed at which above values becomes 0. Okay, so let's draw the basic diagram for the slider crank mechanism. Okay, so here what is given? The crank and connecting rod length are given. So this is 50 mm and this is 200 mm. Okay. Then diameter of the piston is given. So this diameter is given. So T is equal to 80 mm and mass of the piston is given. So that mass is 1 kg. Okay, and the pressure on the piston. So this P, this is equal to 0.7 Newton per mm square. So these values are given. So from these values, we have to find out the net load on the gudgeon pin. Next, thrust in the connecting rod. Then reaction between the piston and cylinder, and engine speed at which all the values becomes 0. So when the piston has moved 10 mm from the inner dead center, okay, so we have to find out what is the value of this angle theta. Okay, so at the 10 mm, initial value will be, so this is the initial construction. So this is IDC. Okay, so this configuration will be exactly straight. So this total length, this will be 200 plus 50. Okay, now it has moved 10 mm. So you can take this reference line, and it is 10 mm from the inner dead center. So your configuration will be like this. Right. Okay. Now this value is L. It will remain same. So this is 200 and this is 50. Okay. So from this we have to find out both the angles, this phi as well as theta. Okay. Now this length, this will be, its total is 200, 250 minus 10. So this will be 240. Okay. Now just by using this sine rule and the cosine rule, you can get the value of this theta. Okay. You can find out all these angles. So here we have to use the cosine rule as we don't know any of the angle. Okay. So just assume this angle as a theta and use, for cosine rule, this is the opposite side. So this is 200 square is equal to 240 square plus minus 50 square plus 240 into cos 50 into cos of angle theta. Okay, so it is a square minus b square plus 2ab cos of theta. Okay, solve this equation and get the value for theta. So this theta, this value is 33 degree. Okay, so this is the only difficult part here, to get the value of this theta. Okay, and once we get theta, we can find out the phi value. So to find out this phi value, either use the cosine rule or use the sine rule. So the sine rule will be, from this sine rule you can get the value of phi. It is 7.82 degree. Okay, and the remaining part is as it is. Calculate the FP, calculate FI,